In this video, I'll help you solve the ALEKS problem called distinguishing solid, liquid, and gas phases of a pure substance. So this problem is going to be talking about a particular molecule, which is going to vary from one problem to the next. This version of the problem is talking about HCl. It's going to give you the melting point and boiling point of that molecule, and what it is asking you to do is pick pictures that represent the molecule at 3 different temperatures. Notice that the temperatures are not matching up with the melting or boiling point. They're different temperatures. Let's start by talking about what these numbers represent. Melting, as you probably know, is the process of converting from a solid to a liquid. The melting point is the temperature at which this conversion takes place. So when a substance is below its melting point, in this case HCl, when HCl is below its melting point, negative 114.8, that substance is going to be a solid. It's frozen. Once it gets up to negative 114.8 and above that temperature, it's no longer a solid, it's undergone the melting process. The boiling point, as you probably know, is the temperature at which a substance boils or converts from a liquid to a gas. For HCl, the boiling point is negative 85.1, which means that if we are above that temperature, if it is warmer than 85.1 degrees Celsius, that substance is going to be boiling, and so it is going to be in the gas phase. At temperatures in between, so if we are above the melting point but we're staying below the boiling point, the substance is going to be a liquid. So between the melting point, warmer than the melting point and colder than the boiling point, our substance is a liquid. Okay, so our job is to find appropriate pictures that match up or correspond to various temperatures for this HCl molecule. There are actually a ton of different pictures for this problem. What I went through and I looked at all of the different options that this had, and I just sort of took screenshots of all of the different pictures of what ALEKS is suggesting to us. Before we dive into all these pictures, I think what we should do is take a look at the temperatures that ALEKS has for us. When you look at this problem, I should say, when you look at this problem, you're only going to see 3 boxes. You're not going to have all these other ones over on the side. So let's start by taking a look at the 3 temperatures that ALEKS is asking us about, and let's figure out what state the substance HCl will be in at these different temperatures. So starting with negative 110 Celsius, negative 110 is warmer than 114, so it's not going to be a solid at that temperature. Negative 110 is falling in this range here. It's warmer than negative 114, but it's colder than negative 85. So in this situation, this HCl molecule is going to be a liquid. We're going to need to find the picture that corresponds to a liquid. These numbers are kind of hard to work with because they're all negatives, and that makes it a little confusing. Negative 34. Negative 34 is colder than negative 114, and so at that temperature, this is going to be a solid. And then last but not least, we have negative 9, which is warmer than negative 85. So at this temperature, it's going to be a gas. And I think that's pretty reasonable to assume that you're going to get one of each. You're going to get a liquid, a solid, and a gas. All right, so our next job is to find the picture, the correct picture that corresponds to each one of these different states. This is where we're going to need to pay attention to the molecule HCl. So the molecule HCl, that means that it has 2 atoms. It's going to have 1 hydrogen atom. It's going to have 1 chlorine atom. And ALEKS is going to depict that using different colored spheres. So you can see that it's giving me a green sphere and like a little white sphere representing those 2 molecules. So the first thing that you should do right away is eliminate any picture that does not have a shape that resembles this guy, this HCl molecule. This is giving us 1 sphere that represents one of the atoms and another sphere that represents the other. So for example, this picture here is just showing us some atoms disconnected. It's not a molecule. There are hydrogens and chlorines in this picture, but they're not attached to each other. It's not the HCl molecule. So we don't want anything like that. I'm actually going to really cross it out. We don't want to be looking at anything like this one. All of the valid possible answers for this problem are going to have molecules where the spheres are all mushed together like this. So we want to eliminate these types of pictures where the spheres are disconnected from each other, separate individual white spheres and green spheres. Here's another one. And this is true for all of these ALEKS problems. It doesn't matter what your molecule is. It doesn't have to be HCl. It could be anything. You don't want to be thinking about any pictures that have the molecules separated from each other. The other thing that we're going to take a look at is look at these guys right here. So this is a picture that would represent two identical atoms, like a chlorine and a hydrogen and a hydrogen, and that is also not what we have going on. We have a hydrogen with a chlorine. So pictures like this, where you don't have the hydrogen smooshed together with the chlorine, you want to eliminate that as well. And again, this is going to be true for all of the versions of this problem. I think here's another one right here where the atoms have been separated from each other. Oh, and here's another one. The atoms have been separated from each other. So we've got it narrowed down to all of the problems here. We've got it narrowed down to every picture has got both atoms in the molecule. And it looks like I accidentally put this picture on there twice. Looks like I put this one on there twice as well. Gosh, okay. All right, so what does this HCl molecule look like at different temperatures? When HCl is in the solid state, what we know is that the molecules take a really structured and ordered pattern and arrangement. They're really lined up perfectly, and that's what we see going on right here. So this picture, which is also duplicated over here, this is a picture of a molecule, any molecule in the solid state. This is what a solid state would look like. That's not a great color for that. This is what a solid state would look like for any molecule. So what you're noticing is the atoms, they're all or the molecules, they're all lined up in a really nice arrangement, really nice pattern. So look for something like that to represent your solid. Now this is kind of goofy, the way this kind of has to work with a screenshot. This would not be the appropriate picture for -110. This picture would be appropriate for this spot right here where I've identified the solid. And again, you're just going to have to kind of bear with the fact that this is a screenshot, so I cannot make adjustments to this bar. Okay, so if we have something that is in the liquid phase, let's deal with the liquid phase next. And I'm actually going to scribble this out because we've got that picture up twice, and I'm going to scribble this out because it's up there twice to make it less confusing for us. If something is in the liquid phase, what we're going to find is a picture that's really similar to the solid, but it's going to be a little bit more disorganized. So I'm looking at this picture right here. There are a lot of molecules jammed into the space. They're all kind of touching each other, but they don't have that same pattern or order or structure to them. This is the picture of what a liquid would look like for any molecule. It doesn't matter what your molecule is. This is the correct answer for a liquid substance. Last but not least, you're being asked to pick what the molecule would look like in the gas phase. In the gas phase, what you're looking for are same thing with molecules, but they need to be spread pretty far apart from each other, which is true for gases. So if you're looking at a gas under a microscope, you're definitely not going to see any kind of order to it, and you're also not going to see a bunch of atoms all mushed together. You're going to see, I keep saying atoms, molecules, I'm sorry. You're not going to see the molecules all smushed together. You're going to see the molecules spread really far apart like this. So this would be a good picture of a gas. I think this is also a pretty valid picture of a gas as well. I'm not totally sure why they're both on here. If for some reason I had to choose, if I had to differentiate between this and this, if ALEKS was asking me to do that, heaven help me, I would definitely choose the one that had the largest amount of empty space, which is absolutely a characteristic of a gas. So I would go with this picture because there's a lot of, if I get rid of this for a second, there's a lot of empty space with nothing in it. And that is true for a gas. So if you're being asked to distinguish this versus this for a gas, pick the one that has the most empty space. This one right here, I would just end up not classifying as anything. Good luck with this problem.